All right, good evening, everyone. Welcome to Informatics 1B tutorial on a Tuesday evening. It is today the 8th of September. Yes, the 8th of September. And tonight we'll be discussing polymorphism. So the main idea behind this tutorial now is to cover polymorphism specifically. So if there's anything specifically that you're struggling to understand about polymorphism, please do drop it in the text. For those that are watching this live, just drop it in the chat channel so that I can see explicitly or specifically what you want to look at or where you're struggling. Otherwise, I'm just going to go with the generic template example we have for tonight. Sorry about that. So the generic template we have for tonight is the UJ module. The one that Mr. Gottwald has already shown you in his his inheritance lecture? I think it was his inheritance lecture. So we're going to be continuing with that example. So first things first, let's go and create our base class, which is going to be for our module, which we're going to call UJ module. All right. And then we always start off with our option strict, on, option explicit on, and our option infer off. We can do that as well. We'll do that as we go along because I want to show you some downcast. I want to show you some upcasting as well because you will need it for your practical most likely. Okay, here's our module. So what are the few things we need for a module? So the first thing we need is we need a semester test. We're going to call this underscore ST1. ST1 as an integer. We can do some interesting things tonight with add a comment this will represent a percentage. Private ST2. Okay, and what else? We need an exam. Anything else we will need? Anything you guys can think of? Anything you think we should add to the UJ module? Instance variables now. What else should we add here? Is there anything we should add? We can go class test, but here's my question. Does every subject have a class test? No worries. So we're covering polymorphism right now. So we've got a semester mark, yes. But now is the semester mark a derived mark, a calculated mark? So is semester test a semester mark a derived mark or a stored mark? Are you going to calculate it and then store it, or are you just going to calculate it? What do you guys think? All right, so you say semester mark. My question about semester mark is, are you going to store the semester mark, or are you going to calculate the semester mark? So what that comes down to is the fact that, are you going to have an instance variable for the semester mark, or are you simply going to have a function that's going to calculate the semester mark? Calculated, that is correct. So what other instance variables can we use inside the UJ module? There's still a few things we can add here. So I want you guys to think about it. What would you add? If you had to control the structure of a module, what would be the template be? What should be there? What's the minimum requirement for a module? Come on, think about it. Code, yes. You've got code. In this case, we'll call it a string. You need a name, that is correct. A string as well. Anything else, or do you think that would suffice for now? Don't let my cursor placement fool you. All right, so we're going to assume that's all for now. So what's the next thing we need to do? What do you think is at minimum required to instantiate or to have this base class work? What do you guys think? Property methods, yes. A constructor, maybe. So let's go and add our property methods. So as I type it out, I want you to decide whether they should be public, protected, private, and whether they should be read-only or write-only. So we're going to do code first. Code. What is it going to be? And if you type something, you have to justify why as well. What is it going to be? I'm going to type it out full until you correct me. Come on, guys. Come on. Take a guess. Even if you're wrong. The only way to learn is if you're going to be wrong. What would you have done? Tell me what you would have done. Would you have done the same as what I'm doing? Or would you have done something else? The same. Okay. So we're going to cover these in a moment. And then we'll discuss whether they're correct or not. So I think let's first get through everything. Like I said, as I type, you tell me if you agree or disagree with me. So the question is, while I type them out, so for the property methods, you have to tell me if they're going to be a public or a protected or a private property method, and whether it's going to be a read-only or write-only, or just a general property method. What do you think? What would you have done? And why? Why is the important part? Easy to guess, but the thing is, if you could say why you would do something, most of the times you'll understand, okay, based on my justification, I can see this is either right or this is either wrong. I don't see anyone typing. Come on, guys, take a guess. Guys and girls. I say guys as a collective, not as a reference. Just in case. I have to be on the careful side, I guess. Come on, what would you have done? Correct me. I'm making mistakes. I'm intentionally making mistakes. You have to correct me. Okay, read only. Tell me why. And which one? Okay, so code, read only. Why? Why is very important. That is correct. Once the module has a code, you can't change it. You don't want it to change. Now, here comes the interesting part. How many codes does Informatics 1B have? The name of the subject is Informatics. It actually has a longer name than that, but let's say it's Informatics. How many codes do you think Informatics 1B has? At this point, 2, yes. So is it seen as one subject, or is it seen as 2 subjects? It's presented as one subject, but if you code it, how do you think the marks are handled? Do you think it's handled as one subject, or do you think the marks are split into the 2 codes? What do you guys think? I'll give you the correct answer afterwards, because I don't expect you to know the answer to that. Question: would you make an interface class for the profits to be implemented on other classes? You can. There's nothing wrong with that. So we can do it that way if you want to. Remember, an interface is kind of it's a checklist. It tells you what to expect. The way to think about an interface is something that doesn't really fit the description of the class, but can be used with the class. That is where you want to use an interface. Now, if you think about module, an exam, a semester test 2, a code, and a name is things that you strongly associate with a module. Now, let's say you want to link the lecturers. You want the lecturer's name in here. Then you can potentially add a interface for the lecturer's details, or any functions that are related to the lecturers, or any functions related to students specifically. Because that is now loosely connected to the class. But nothing stops you from using an interface. You can use an interface as a checklist if you really want to. There's nothing wrong with it. I know of people in industry that do that. I don't always agree with it, but it is one of the standards. I know of people that use it as a checklist, literally as they would type it out first in the program and make sure to call it everywhere, so that they remember to do certain things, so they don't forget about it. All right. So let's go from the top. I want you guys to tell me, and I'm going to minimize this so that we can all discuss it quickly. I want you guys to tell me from the top to the bottom, and I want you all to tell me, would you have made it a public or protected class? Let's not make it private yet. And whether you would have made it a read-only or a write-only course, or just open. Open, we'll assume it's both, or just say both. So read-only, write-only, or both. What would you guys have done? Guys and girls, what would you have done? All right, so I assume all of you are starting to type it now. So let's look at it. Code, read only. Why? Because you don't want a code to change once it's been set. It will cause absolute havoc. A name, it's one of the things where it's a bit iffy, but it's kind of like a code where you don't want it to change once it's been set. Ideally. Now, depending on how the application specifically works, you can have the potential to have it change. But in this case, we'll make it that you have to set it. It's the correct one from the get-go. Now, what does that mean? If we have a read-only function, property method, sorry, if we have a read-only property method, what does that mean? You can tell me. No, it's not a need a write only. You're on the right track, but I think your wording is just differently. I think you understand it correctly. You need a way to write it, but it's not a write only. What is it? What do you think is missing? It's not private either. Constructor. Just keep in mind that those values needs to be set. Somehow you need to set those values, otherwise, it's an issue. So in a constructor, you'll set the name and the code to ensure that they have been set, but they cannot be changed once they've been set. All right, now let's talk about our functions. The first obvious function is going to be our semester mark function, and that's going to return an integer value, which is our semester mark. I'm assuming everybody is happy with that. Nothing special there. Before we give it code, we're also going to add our final mark function. So the first case, what we have is we have a function to calculate the SM mark. We've got a function to calculate the final mark. Everybody happy with that? All right. So the way we calculate our final mark is we take our semester mark, plus our exam mark, and divide that by 2. Does everybody agree with that? Actually, no. I want to keep that an integer. Everybody agree with that? You want to not change. Okay. So you're talking about constructor here. So we only construct the variables we want to not change. In this case, yes. You can have a constructor that will fill in all the values. So let's say you do this post-processing. then you'll most likely do this afterwards. But if you do this as pre-processing, then you're looking at it from the viewpoint of the values are known beforehand, but the semester mark, the semester test marks and the exam mark are known before. So in other words, for that, you would have a constructor for the module code and the name to create the module itself. Everything else is unknown, so they are left empty until we set them using the property methods. But if there's anything that's a read only, we need to somehow set that, and that's only with the constructor, because that's the only way we can change that value is with a constructor, because otherwise we don't have the access to it. So essentially, we're not even changing the value, we're creating that value. The first value it's given, that's the value for life. It can never be changed. Well, unless you change it in the code itself, but that is for something else. Expression does not produce value. How to fix it? Okay, you'll have to give me the code that causes that, because I can't think of that. We'll try and duplicate that. Just tell me where to change my code to duplicate the specific error you have. But from what I'm seeing is that might be in a function with a return. We have a path where there's a possibility of no return. The pop-up says expression does not produce value. So I'll have to see the code to tell you what's causing that error. Unfortunately, I can't think of off the top of my head what causes that error specifically. All right. Now for the semester mark, how do we want to do this? Are we going to go with a standard evaluation, saying that we only assume that we have the two classes and that will calculate the semester mark? Or are we going to calculate the semester mark on some other way? All right, Masandu, we'll come back to your question maybe a bit later. Maybe after the recording stopped, you can just show code and I'll tell you where the error is. Otherwise, we're just going to go off track in the chat now. All right. So the first assumption we can make here is either there is a pre-calculated formula that we can use. For instance, we can say return the two semester mark values. So we take ST1 plus ST2, and then divide that by 2, and that will give us our semester mark. So the return of this will be a double, so I'm just converting it to an integer, which should round up, which is what we want as well. So our semester mark 1 and our semester mark 2 weighs equal amount. So we just take that and divide that by 2. But that's because we're assuming we're being given the percentage for the two tests. If we're not given the percentage, then we will have to go and calculate that first, but that will require extra parameter values. So right now, ST2 and ST1 has an equal weighting, so they both count 50% towards the semester mark. If you want to make it specific in terms of a formula, you can always go with, you can multiply by 0.5, and that will give you the percentage out of 100. Making sure that your final, whatever you multiply with in the sequence, the additions should always add up to at least 1. So if you take the two multiplications and that adds up to 1, then you've got your result. Right. Yeah, there we go. All right, so there's two ways in which you can do that. Either way, it doesn't really matter to me as long as you get to the correct value. Percentage can be a decimal, yes, but the way it's calculated, you'll see that you've never seen a decimal value for your percentage. When we do something like the top achievers or anything, we do take the percentage into consideration. But think about how you received your marks. Have you ever seen a 0.1, 0.2, 0.3, 0.5 to up until 0.9 on any of your results of your marks being given to you? No, that's because it's rounded up. So if you end on, so ideally you'll end on a 0.5, which means anything above a 0.5 gets rounded up to the next value, and anything between 0.0 and 0.5 if I say anything below 0.5 gets rounded down to that value. But generally it always ends on a 0.5 unless it's an actual calculated formula where we just truncate it then if it's anything less than 5. So just once again round up or round it to the closest integer. All right. So everybody happy with this? We've got our instance variables. We've got our property methods, which we've made to read only so they don't change the code and don't change the name of the module. We've got our semester test 1, our semester 2, and our exam. We've got a constructor so that we can at least instantiate the code name and the module code and the module name. And then we've got a base formula for our semester mark, and we've got a formula to calculate the exam mark. All right. So let's start off with our first subject. What are we going to call our first subject? How about the subject that you all love? I know you love this subject. We'll take maths. Yes. See, I told you. I knew you'd love that. I know you love mathematics. Mathematics is awesome. Keep in mind, I say mathematics is awesome. I didn't say that people teaching mathematics is awesome. Oh, that can get me into so much trouble. I like the math people. They're awesome. Off stream or off recording, I'll tell you who my favorite lecturer is there. All right. So, mathematics. Are there any additional things that we need to add here? So keep in mind, we've got the base structure here. What are you talking about? Mr. Cottrell loves the mathematics people. He adores them. He can't praise them enough. Oh, Mr. Cottrell is here, so he can dispute that. Okay, so class test. So you have class test there. So we need to add class test. You guys shouldn't judge your mathematics. It's not easy. I don't think it's an easy subject to give, especially for a large group. It does help if you have a passion for the subject. I have to add that. I must say the person that taught me mathematics made me love mathematics, and then there's one lecturer that taught us one of the versions of mathematics. I won't say which one on a recording, but we actually, the entire class signed a petition to have her removed, and it did not help either way. I don't think she should be a lecturer, but I'll never say her name out loud. All right, so we've got class test. So now, what do we need to add here? Is there anything we're forgetting here? What do we need to add? Comments and tut test. I don't think we should add that. Semester mark, okay, but there's something missing here. Yes, it needs to inherit. If I can spell it correctly. So it needs to inherit from UJ module. Otherwise, we can't get access to those other things. So now it's giving me an issue, and the issue here is the fact that we declared a constructor. The moment you declare a constructor is the moment that the subclass, or the derived class, needs to declare one as well. Right, so it's a private sub-new. At minimum, we need to at least handle a code and a name. And then we can call minus.new, and then you can just pass those two values along. Right, so we're all set there. Anything else we need to add here? Keep in mind that class test is an array of class tests. Is it a specific amount of class tests, or is it to be determined at runtime? Right. So we resized or redumbed our array to make sure it's of the correct length. Now that we've done that, we have to consider this is still a UJ module. So what are the things that are required for this specific UJ module? You need to make sure that we calculate the semester mark. Now, for the semester mark, we see we've got an addition, and let's just go and add the property method here. Yeah, isn't there? Yeah, if I get this now status, to return the specific value that we want. And then we also set the specific value that we want. All right. Is it necessary to make is it necessary to make is an index? I'm assuming you're referring to the fact that I have this parameter list here. Oh, to make it an index. You can make this anything. You can make it it's just a variable declaration that represents the number being passed along. I'm just calling it index because it's essentially what it is. It's just an index. It's a very applicable description of how it's going to be used. Okay, someone's hand is up. was up. The Tower, do you have a question for me? If I pronounce your name correctly. Mistake. Okay. I assume you were just stretching there. All right. So I'm just using index as a description because it's used as an index. So it's the most appropriate description for how it's being used. Generally, a variable, you want to make a variable's name as descriptive as possible so that you know exactly what it's being used for in your code. All right. Now, we have a semester test. Now, remember I told you guys you need to correct me if I'm doing something wrong. This is where it comes into play. So, we need to calculate our own semester mark in terms of mathematics, because the mathematics subject has a different way of calculating the semester mark because you need an average for your class test. So, how will you calculate your semester mark here? And I'm just going to create a temporary variable for us. Okay, are we going to calculate the semester mark? Oh yes, Shogwe, we're getting there. That is the mistake that you guys did not tell me about. Remember, I'm always going to introduce mistakes in my code when we do the tutorials because you need to learn how to identify them as well. So the fact that it's underlining it here is the fact that it's referring to the fact that it needs to be overloadable in any case. So we have that indication of, in this situation, we need an overloadable or overridable function. And then in our math, we just need to override it. Overrides. All right. Now it's going to complain until we have a return here. So how are we going to calculate this semester mark here? So let's look at the formula first. Let's determine what our formula is going to be before we determine what we need for this formula. So what is the average mark going to be? Or what's the semester mark going to be? How are we going to calculate it? You guys tell me. Give me the ratio split what you want. How much are the classes going to count? How much is semester test 1 going to count? And how much is semester test 2 going to count? Okay, you say 50-50. You need to tell me class test, this much. Semester test 1, this much. Semester test 2, this much. Can't be 50-50 because there's three items. Make 40%. Once again, there's 3 items, not just one. ST1, okay, 40. And then semester test 2 and the class test, how much are we going to make that count? ST2, 40, okay. And then the class test 20. Right, so let's take that formula. All right. AC1 and AC2. Okay, hold on. 50, 40, 40, 20. You guys don't like your semester test. Okay, let's go 40% for your semester test, and then we will go 20% the class test. So let's first deal with the semester test. So ST1, easy peasy. We just multiply by 0.4, and then we've got our 40%. ST2, we'll take ST2, multiply by 0.4, and we've got our 40%, and class test. How are we going to do this? So what are we going to use here? Are we allowed? And I want you to tell me if this is allowed. So class test is an array. You all agree with me there. Be allowed to do that. Allowed to do that. First, I want you to tell me I'll be allowed to do that, and secondly, whether it will work. So just ignore. Okay. So just ignore what it's causing an error. Yeah, no, I have fixed that. It's just complaining because we're multiplying by a decimal value, so technically the result's going to be a decimal value. But I'm talking about this. Can we class test.average? Yes. Now tell me, why are we not allowed to use built-in functions? Do you know what this function does? It says average. It says computes the average of a sequence of integer values. But do you know how it's calculating the average? Ideally, the situation is given the code for how it's calculating the average, like the exact code how it's calculating the average. So ideally, when you're working with calculations, you should ideally do all the calculations yourself, unless it is a derived calculation of a more complex nature, of which you will be told how the formula specifically works. The more you get on built-in functions, the more your program can break with upgrades and maintenance and all of that. So in this case, you should be calculating the average yourself. So you can have a calculate class test average. Yes, I know it's a very long function name. So you should have a calculate average function. My mind is not here today. Fine. And then we just need our for I to, and then test the length of our array, in which case we can go yeah. And then we can just go and then once you're done, you just return that value, the sum divided by the number of items. Now you can't put this into a you can't put that into a double. You can put that into a temporary variable if you want to. The moment you use a value, a specific value now, more than once, you can put it into a temporary variable if you want to. But if you're only going to use it once, then honestly, there's no need to really put it in a temporary value. But in this case, you can put it in a temporary value if you want to. All right. So we calculate the average for our class test, and then we have our results, and we output that results. Making sure we output that result. Okay. Now you can put a return here directly if you want to. Like I said, you can either put your calculation in temporary variable, but seeing as we're calculating it once, you can potentially also just say return and then add that as the return. There's no problem doing that. I'm just showing you the other way of doing it. I'm always going to try and show you the other way of doing it. If I showed you one method once, I'm going to try to show you the other method the other time. All right. Now, do we have to calculate final mark year as well? Who can tell me? While you think about that, I'm going to add another class. We're going to call this one infos. We'll just call that infos. Always remember to add our options to the top. Okay, one person says assume. Okay, one person says no, one person says yes. What do you guys think? Is it needed? What's the beauty of polymorphism? Let's start there. You can tell me. We mentioned it in class. Why is polymorphism so beneficial? Ooh, silence. You guys not listening in class? What was the one benefit of polymorphism? Come on, guys, take a guess. Even if you're wrong, still take a guess. Oh, that's why it's giving me an issue. It makes it easier to read code. It can make code shorter. It removes all the duplications, but that's not specifically why. Can use multiple classes in a single variable? Yes, but that has more to do with downcasting. Write less lines of code? Yes, that is a benefit. All of these are benefits. That is true, but I'm looking for a specific one. What does polymorphism stand for? What's the Oxford definition of polymorphism if you break it up into poly and morphic? Multiple forms. All right. So what in this code set currently qualifies as polymorphism? What have we done that's similar in name but has multiple forms? the different modules. So the different modules count as inheritance, but inside the modules, inside each module, what is similar but different? It has multiple forms. So it's the same in each module as it's there, but the actual calculations themselves differ. You say final mark at this point. Does the final mark differ? Calculations. You're on the right path, but it's still something missing. Come on. The semester mark. The function semester mark. Why does that count as polymorphism? Specifically now. You can tell me. Bill should know the answer. It appears on multiple. It appears on multiple forms. Yeah. It is there on all modules, and it is different for each module. All right. So it's not specifically different for each module. Yeah. We got the length function here. It's not specifically different for each module. What am I doing wrong here? What's going on? Am I using the right variable? I declared it as an array up here. To practicals dot. Am I making a spelling mistake here? No spelling mistake. Is it a spelling mistake? Ah, TH. You know, you always look over those small things. You just type and you think you've got it correct without double checking it. Hi. All right. So, our semester mark is calculated differently for each module. But now, the question is our final mark being calculated differently for each module? So our semester mark calculates as polymorphism because it has multiple forms. Depending on what module you look at, the actual calculation itself will differ. But when you look at the final mark, will the final mark differ? What do you guys think? Will the final mark differ? The calculation of the final mark. Just think about it. The final mark is the semester mark plus the exam mark divided by 2. So will the final mark differ? I'm not going to use the temporary variable this time. I'm just going to do the calculation straight from here. I think for us, our practicals are a bit more important. Let's take calculate average. And we'll say that counts, it counts 40%. Then we've got our first semester mark, ST1. We'll make that count 2. Yeah, we'll make that count 2. And then we'll make ST2, your practical test, count. Let's see, what do we still need for? Right. So right now, you're probably thinking, okay, but we never actually calculated the final mark. Okay, if you don't mind, I'm just going to do that inside the button itself. So just excuse the fact that I'm not going to do a proper interface. Otherwise, we will run out of time. Right. A few things we need to know. First thing, let's create our variable. Our variable names will be subjects as UJ module. Right. So we will have multiple subjects of type UJ module. How many we have at this point? Let's say we're just going to have about 2. So we'll read them our array and we click on the button just for the sake of having it there. So we'll read them the subjects to 2. We can do it manually in this case, just to save us some time so that we can see that it's working. And we're going to make a temporary variable for subject 1 as math. Sorry, I see my Blackboard screen went black, so I'm assuming you can still see and hear me. Just tell me if that's not the case, please. We've got our subject 2, which will be IFM. And then we need to create, now keep one thing in mind. When you instantiate an object of these classes, you need to make sure that before you upcast a function, so before I pass these into this array that will be of type UJ module, I first need to fill in the information that's relevant to the class itself. So because I'm doing it manually, I know I'm working with maths and I know we're working with infos, but ideally you would have to do a test, and we'll be discussing that in class tomorrow. You'll have to do a test to see which one you are using or which one you want to use. So in this case, we'll take subject 1 equals new math, and then we'll have a code. We'll call it math 1a. We'll have a name. We call it FUDMaths, and we will have an array size of 1. Just to make it easier for us, just to set the array. Then you've got subject 2, new IFM. You'll have IFM 1, let's say 1B and 1A. We have informatics. Also just one size for the array, just make it for us. And then what we do, the first thing we need to do is we need to make sure that we set the value. So subject 1 dot class tests for the 1 item. is equal to, are we going to say 100% to make it easier for ourselves? Subject 2 dot practical 1 equals 100% because we are good students, or our program is a good student. Okay, then can we go to the array now? Yes or no, and why? Can we do that now? Is there an issue if you do that now? Oh, I see, I missed the question. So how do we know when to use underscore classes and when to use class test, or is it there always? Or is there always an underscore when we're using it in the class? Okay, so how Mr. Cottrell explained it in the lecture when we did instance variables or property methods is generally if your property method inside your class itself, if your property method contains validation, then ideally you would use your property method at all times. Because generally you don't actually want to use it directly, like we're using it here. Sorry, like we're using it. Yeah, like we're using it here. Oh, sorry, over here. So generally, you always want to use the property method and not the instance method, but either way is fine. We won't penalize you if you use the instance variable inside your class itself. We will penalize you if you use the instance variable outside the class, where you'll get penalized. So inside the class, it's up to you. If the property method itself contains a form of validation for the output or the input, then you would use the property method because that validation is, it's already inside the method. You don't have to pre-validate it before passing it along. But if there's no validation inside the property method itself, you can just use the instance variable directly. It doesn't matter essentially. All right. Then next question. Yes, all values have been set. Yes, because we have all the necessary information to the specific classes. Yes, that is crucial. So for those specific classes, for maths, class test is a math specific attribute, and practical is a IFM specific attribute, which means we need to set those before we can call the array itself. But now that the array has been called, can I go and change the semester test marks? So we'll go .st1. Excuse me while I am going to be a little bit lazy. So we've got st1, st2 for subject 1 and subject 2, and then we'll just give that a value. So let's say for your first test you got 50%, for your second test you got 50%, for infos your first test you got 50% because you don't do good in theory, but for practical test you got 100%. All good. No, not 30%. Never less than 50%. Anything less than 50% is a fail. And we don't fail. We should not fail. All right. 30% is not good. No good. No bueno. All right. So when we calculate this, now I want you guys to think about this carefully when we call this function now. I'm going to do a message box. We're going to do a for loop to show you that we can call both of them using the specific for index as integer is 1 to 2. Yes, I know it's set values, but I just want to make sure that you can see that you can call it specifically with all right. Now message box, and then that would be our output. So we need to convert to string so that we can see our values and not break it like that. Okay, so subjects index dot semester mark, which will return a integer value to us, which we convert to a string so that we can show it in our message box. All right. Now, we want to do the same for our final. So I want to show you something. So this, specifically this, is called downcasting. This is something we'll handle formally in class tomorrow, because what we're doing is we're passing a child into an array of the parent type. The subjects is of type UJ module, whereas subject 1 is type math, which is a child of the parent class, and subject type 2 is a child of the parent class. So we can do upcasting into that. The moment you want to cast it back into a math subject, so let's say you want to go and add a class test, you'll have to downcast it back into a math test. So for instance, you'll have to say, assuming, let's just create a new one. Subject 3 as math. So here, if I want to pass subject 01, which is the math class, into subject 3, we can do that because math subject 3 is of type math subject 1. Right. Just ignore the error that it's giving right now. It's because option strict is up. So this is downcasting. This is something we're also going to discuss tomorrow, and I'll show you how to handle that. But the idea is if you pass something up to the parent class, so from the child to the parent, that is upcasting. If you want to pass it back down, so from the parent class back to a child class, that is downcasting. But there's something special you need to do for downcasting first, which we'll discuss tomorrow. All right. Now, I'll do it tomorrow formally. I don't want to confuse anyone too much right now, and I don't want to spend too much time on it right now. So while we are here, let's quickly do our formulas or our calculations so we know what we're expecting. Because we're giving it values, we know what to expect. So what I want to do now is let's quickly go and grab our formula. Because we're going to test now, we just want to make sure that we have the correct formula and that the formula is working. And let's just add one more. All right. So this was the math formula, this was the IFM formula, and this was the base formula. So if is the formula, what is the answer going to be for the math subject? So practical was, or class test was 100, prac 1 was 50, prac 2 was 50. So what is the result going to be here? So we've got 20% here, 20% there, and 20% there. So we should get 60% for our semester mark. Do you all agree with me there? Just say if you don't agree with me. A few of you are probably ripping out your calculators right now. So while you verify that, we'll continue. Then for informatics, we calculate our average practical mark, which is only 1, so we have 100 there, so that would give us 40%. We have our first semester test, which we did badly in, so that would give us 10% there, so 50%, and 100% for our second semester test, which means we've got 40% there, which gives us 90% as a final mark. Do you all agree with me on that? Anyone that disagrees with that? Is it too late for maths for you guys? Are you guys still there? Have I lost you now? We're setting up our test, so we need to know what the output's going to be. Do you guys agree with that? Okay, we've got one person that's still alive. Right. Now, just for the sake of double checking, whether it's the parent class or the base class administration being executed, we're going to calculate what the base class calculation would be for maths. In this case, it would be 50%. And for infos, it would be, correct me if I'm wrong, 75%. Right. So in this case, if the derived class calculation is used, we'll get 60% for the math test, 90% for the infos semester mark. Sorry, math semester mark will be 60%. The infos mark will be 90%. And if the base class formula is used, we'll get 50 and 75 respectively. All right. So let's test and see if that works. Now I want to run it. Just excuse the ugly form. So we run it, and we know our first output was for our math test, which is 60. So we know that our semester mark calculation is based on the child's calculation, and 70 for our info. So mistake there, and then 30, and then now what is, oh, it's because of the exam. Let's just do that for a second. Right, so there's something wrong here. So we gave it 100 for the practicals, so that should be 40% plus 10% for there, that's 50, plus 100% there, that should give us 90, which means there's a problem in our formula over here. This is one item, plus minus one item, 40, 20, 40. It must be in this calculation that something's going wrong. Can't think why else it will give us a 70%. Did I miss a bracket somewhere? Ah, yes. Thank you. You are absolutely right. I missed that bracket, which means, yeah, okay, I did that in the maths one. Okay, that's why we didn't have an issue with maths. We just close this with a bracket. These small things, generally the small things that break the problem, even though the formula looks correct. Okay, so let's just quickly double check that. We've got 60, and let's just step over it. and we've got 90. So our test data is correct. So now let's go and calculate our final mark. Now, keep in mind that for our final mark, it is only specified in the exam. So our final mark is our semester mark plus our exam mark divided by 2. So I'm not going to give it an exam mark, which means it is going to be 0, just to check whether it's executing the right function. So in this case, let's just comment that out. In this case, what will the result be for maths? Should our result be? So we've got 60% as a semester mark. If we take the exam mark to that, which we currently don't have, so it will be a 0. So we take 60 plus 0 divided by 2, we should get the 30. And if we take the infos, we'll take the 90 divided by 2, which should give us 45. Sorry. You all agree with me there? So the execution of the final mark, which uses the semester mark, should be the result of the child class. So what I'm referring to here is, even though the parent class calls the semester mark function, it's going to call the semester mark function relevant to that specific object. And there's a way to test it and see if that is correct, and that's by running the function. So we run it, we test it. So we still get 60 for our maths semester mark. Sorry, let me just remove that point. Still get 60 for our maths semester mark, still get 90 for our info semester mark, and our test data say that the next one should be 30, which is our math semester mark, and 45, which is our info semester mark. So as you can see, the semester mark itself, it's not calling this formula, but calling the formula relevant to that specific child, which means, or that specific object, which means when it's calling a math object, it's referring to the semester mark calculations inside the math class. And the same thing for infos. When it's calling the semester mark, it's calling the semester mark that's relevant towards that class, which is the infos one, right? The second one. And the only reason why we can do that in a generalized array is because of polymorphism. So it's because we overwrite the function, and then the main class sees the overridden function and uses that function when it gets called. So even though the base class still uses the formula, it will make sure to use the correct function in that formula and not just the base class itself. And that's the beauty of polymorphism. Polymorphism is the fact that we have an overridable function and that we override that function, giving it more than one possible form, but using it as well. Everybody okay with that? Can everybody understand why this is useful when looking at how we use it? Okay. Is there anyone that doesn't understand the fact that if we talk about polymorphism, we talk about an overridable function, or a function that is overridden? Is the fact that you've got a function, multiple functions with the same name, but separate or separate executions, different executions for each one of them. And I'm saying it specifically for that because you can have it in a inheritance structure, but you can also potentially have it in a single class. But I'm not going to show you that. That is something you can go and practice, and you'll see it next year as well. All right. Now, having said all of that, is everybody comfortable with what I've showed you? And is everybody comfortable with how to use it? When it comes to the input, we'll discuss how the input specifically works tomorrow. And because then I'm going to teach you enumeration. So enumeration is going to be useful when we input data. We decide which one is for which. And upcasting and downcasting specifically or formally is going to be discussed tomorrow. So the array, which makes polymorphism that nice to use, is we're only going to discuss how to handle that really tomorrow. The only thing you have to understand under polymorphism right now is the fact that it is a function that overrides another function. Okay, you say you're uncomfortable with defining polymorphism. Let me ask you this. Are you comfortable with defining a overridable function and then overriding it? Okay, that is polymorphism in our definition, in the way we use it. So by replacing the words overridable and overrides in a theoretical concept, we replace it with the general term polymorphism. Because that overridable function means that you now have another function of the same name, potentially with the same parameter types, not always, but you've got a function of the same name, but a different computational output. Yes, that's the whole concept, is you've got functions of the same name. Now, whether it has the same parameter list or not, it doesn't actually always matter, because polymorphism focuses on the fact that you've got multiple forms. So you've got a semester mark with multiple outcomes. Yes, as Mr. Cottrell says. Same method, different outcomes. So is that the demonstration of polymorphism, sir? Yes. This semester mark, you've been using polymorphism for half of the semester without even realizing it. So this overrides, and that overridable, that's polymorphism. It's one of the forms of polymorphism that we're going to show you. There's multiple forms, but I'll be introducing the concept to you. The use of the one array is upcasting, so you can use polymorphism inside the array and have the correct execution of that function. This touch should be uploaded by tomorrow morning, but it's available on Blackboard it should be available within about 10 minutes on Blackboard specifically. But on YouTube, it will only be available tomorrow morning or tomorrow. All right. So is there any other questions you guys have for me right now? Anything you want on the recording? Because if there's nothing relevant to the polymorphism aspect here specifically, then I'm going to stop the recording. And then we can continue with any questions if you have any additional questions or you want me to code anything additionally out for you. I am okay with that. Just want to check something quickly. Okay. So upcasting is basically chopping the specific functions. Choosing. I'm assuming he was trying to say choosing the specific function of the derived class. Yes. So in this array that we use, when we call the function, it chooses the right function based on the object itself. So the object defines which function it's going to be called, and that is what makes polymorphism so powerful. That's one of the benefits of polymorphism, because we can have this array of type object. If I say type object, then it's a general object. There's a specific word for it in Java as well. There's I think it's template. It's basically you've got an array of items, and then your item type When you call the item type function specifically, then it will choose the correct function as long as that function exists in that item type. I'll get the correct word for you. I haven't used it in a while. It's represented by a T. So when you get to third year, you'll use notation which indicates a type, but it's a type determined at runtime. I just can't remember what the specific name is of that term. Okay, so don't worry about upcasting and downcasting too much. We're going to discuss it in class tomorrow formally. So we're going to show you an example of what is upcasting and what is downcasting. So don't stress too much about that. That only comes tomorrow. Tonight's start is all about the polymorphism aspect, the fact that you have multiple functions of the same name, different computational outputs. All right, so what you're referring to now, if that get PCM is only inside the infos class, then you cannot call it within the array. Because the moment you try to call it within the array, it will tell you that there's an issue. So let me actually show that to you. Let's add a public function. We'll call it PCM, and this will return a integer. And just for the sake of a return, we'll say it returns 1. Right. Now, this is only available inside IFM. It's not available inside maths, and it's not available inside UJ module. Now, keep in mind that we have subject 2, which represents IFM, which means that if we call subjects 2 dot, do you agree with me that we're calling the fact that we're calling this item? This item, which is informatics. All right. And inside informatics, we've got the function called PCM. All right. Let's try and call it. It's giving me a red line. What does the red line tell us? It says PCM is not a member of UJ module. So this array has been upcasted to type UJ module up here, which means it can only call the functions that are inside the base class. If you override a function that's in the base class, then it will allow you to execute the overrided or the overrode function. So for our semester mark, the semester mark function is inside the base class, but the implementation, the correct implementation, is found inside the derived class. But because it overrides the base class version, it uses the one in the derived class. But because PCM is not inside the base class, it cannot call PCM, because PCM is not a member of UJ module. So when you upcast, you're basically telling it this object now represents a UJ module, so it can do everything a UJ module can do, and it can use the functions it defined that's better than the UJ module ones, but it can't use the functions only specific to that object. That's one of the downsides of upcasting. So with upcasting, you can get a lot of generic function out of it using polymorphism. But if you want to use specific class-based functions, you have to downcast it back into the original class that it is, or back into the original type that specific object is, if you want to use the class-based functions. And there is a different way of doing that, but that will show you later on in one of the tutorials. All right. So like I said, we'll discuss that formally tomorrow, because that's part of upcasting and downcasting. But for now, all you have to understand is with with upcasting, with polymorphism, polymorphism is just the fact that you have an overridable function and that you override that function. It also works with overloading a function, but that's a term you'll only get used to later on. Right. So don't worry too much about upcasting and downcasting. We'll discuss that tomorrow, and we'll discuss it in Thursday's stuff as well. But I am going to stop the recording here now before the recording gets too long. If you have any additional questions, I'll still be online. You can still ask those questions. It just won't be in the recording. So for those listening to the recording, I hope you have a lovely evening further. And please do make sure that you attend the TUTS and the live lectures, at least the live lectures, or the recordings of the live lectures at minimum. All right.